Okay students, Unit 2, the quantum mechanical model of atom. The quantum mechanical model of atom. In this session, I am going to teach the energies of orbitals. Orbitals ஆற்றல்கள் in hydrogen atom. In hydrogen atom H1. So electronic configuration 1s1. In a hydrogen atom, the only one electron present in the orbital. For such a one electron system, the energy of electron in the nth orbital is En is equal to minus 1312.8 into Z square divided by N square kilojoule mole inverse. To write from this equation, we know that the energy of orbital or the energy of electron depends upon the principal quantum number. The principal quantum number n. Right? From this equation, the energy of electron or energy of orbitals depends upon the principal quantum number n. The n value is increases. The energy of electron, the energy of the orbital or energy of the orbit are also increases. Energy of the orbitals 1s, 2s, 3s, the n value is increases. The energy of the orbitals are also increases. Right? The energy of the orbitals will be in the following order. The energy of the various orbital will be in the following order. So 1s is less than, the n value is increases, the energy of orbitals are also increases. Okay, so in second orbit 2s is equal to 2p. Okay, the 2p orbital is more energy than 1s orbitals, and less than 3s equal to 3p equal to 3d orbitals, and less than 4s equal to 4p equal to 4d equal to 4f orbitals, less than 5s equal to 5p equal to 5d equal to 5f orbitals, less than 6s equal to 6p equal to 6d equal to 6f orbitals, less than 7s. Right? To increase the n value, n1, 2, 3, 4, 5, 6. To increase the n value, the energy of orbitals are also increases. So 1s, 2s, 2p, 3s, 3p, 3d. To increase the order. The electron in the hydrogen atom occupies in the 1s orbitals. Okay, so 1s orbital is a lowest energy. 1s orbital is a lowest energy. This energy level is called ground state. Ground state energy level. Say lowest energy level. This energy level is called ground state energy level. Thus electron requires some energy. Electrical energy. Requires some electrical energy. The electron move from higher energy such as 2s and 2p or 3s, 3p. Okay, so this electron requires some energy to move higher energy level such as 3s, 3p. Okay, so or 2s, 2p. This state is called excited state. This state is called excited state. Okay, the ground state is 1s1. It's a ground state. Okay, in the electron absorbs some energy, transfer from lower energy to higher energy. Lower energy to higher energy. The higher energy is called excited state. Excited state. However, the above order is not true for atoms other than hydrogen. However, the above order, so 1s less than 2s equal to 2p, less than 3s equal to 3p equal to 3d. So, however, the above order is not true for atoms other than hydrogen. Multi-electron system. Okay, hydrogen வரைக்கும் அந்த சிஸ்டம் ஒபே ஆகுது. ஹைட்ரஜனுக்கு அப்புறமா இருக்கக்கூடிய மல்டி எலக்ட்ரான் சிஸ்டம் வரும்பொழுது இப்போ நம்ம இதுக்கு முன்னாடி எழுதின எனர்ஜி ஆர்டர் is not true. Okay, for such systems the Schrödinger equation is quite complex. So Schrödinger equation square complex ரொம்ப கடினமானது. Schrödinger equation படி அதை எக்ஸ்பிளைன் பண்றது ரொம்ப சிரமம். For these systems the relative order of energy of various orbitals, the relative order of energy of various orbitals is given approximately by the n plus L rule. N plus N rule. So n is a principal quantum number. So L is a azimuthal quantum number. Right? N is a principal quantum number and L is a azimuthal quantum number. So n is equal to 1, 2, 3 and etc. In L value S equal to 0. S equal to 0. So P equal to 1. P equal to 1. Okay. D equal to 2. D equal to 2. And F equal to 3. Okay. So N is a principal quantum number and L is a azimuthal quantum number. Right? So the n plus L value, the n plus n value, the lowest the n plus n value, the n plus L value is lowest. Lowest. The energy are also lowest. The energy are also. The energy of orbital, energy of orbitals are also lowest. Okay, lowest, right? The n plus L value is lowest. The n plus L value is lowest. The energy of orbital are also lowest. The n plus L value is same. Okay, the n plus L value is equal to 4 in one orbital. In another orbital are also 4. Right? The same number of n plus L value. The n value is least n value is lowest energy. The least n value is lowest energy. For example, 3d and 4p orbitals. 3d orbital and 4p orbitals. The same n plus L value. The n value is 3 and L value is equal to 2. So 3 plus 2, 5. 3 plus 2, 5. In 4p orbital, n value is equal to 4 and p value is equal to 1. P value is equal to 1. So 4 plus 1, 5. The n plus L value is same, 5, 5. Okay, which one of the orbital is lowest energy? The n value is least. The least n value orbital is least energy. Least energy. You write the following examples in 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 5s, 5p, 5d, 5f. Okay, 4s, 4p, 4s, 4p, 4d, 4d, 4f, 5s, 5p, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f and 7s. 7s. In 1s orbital, n value 1 and L value 0, the n plus L value 1. Okay, 2, S value 0, 2. 2, P value, L value, P orbital 1, so 3. In 3s orbital, so 3, 0, 3. Okay, so same n plus L value. Which one is least? The n value is lower n value orbital is least energy, right? 3p, 3p, 1, 3 plus 1, 4. 3d orbital, n value 3 and d 2, so 5. In 4s orbital, 4, 0, 4. In 4p orbital, 4, 1, 5. 5, 5, right? The next 4d orbital, n value 4, d value 2, so n plus L value 6. 4f, 4, n value 3, 7. 5, 0, 5. 5p orbital, n value 5, p orbital value 1, 6. In 5d, n value 5, d value 2, 7. In 5f orbital, 5, f3, 5 plus 3, 8. In 6s orbital, 6, s0, 6. Right? And 6p, 6, 1, 7. 6, 1, 7. And 6d orbital, 6, 2, 8. 6, 2, 8. And 6f orbital, 6, f3, 9. In 7s orbital, 7, 0, 7. 7, 0, 7. Right? So, the increasing order of orbitals using n plus L value. Using n plus L value. The 1s orbital is the least energy. 1s orbital. Next, the value 2. So, 1, 2. 2, so less than 2s orbitals. 1s orbital and higher energy 2s orbital, so 2, 3. Okay, same n plus L value. Same n plus L value. The n value is least in 2p orbital, so 2p less than 2p and 3s, 3s and next 4. The 2, 4 values. 4 is 2, 4. Are you right? 3p and 4s. 3p and 4s. But 3d is 5. N plus L value is higher than 3p and 4s. The 3d n value, n plus L value is higher than 3p and 4s. Are you right? So 3p, 4. 4s are also 4. So which one is least energy? The lower n value. The lower n value given orbital. So 3p less than 3p. Next 4s. Right? In 4s orbitals. Students, புரியுதாப்பா? Same value இருக்கு. இதை விட ஹையரா இருக்கு. அப்ப இத ரெண்டை விட 3D ஆர்பிட்டாலோட எனர்ஜி அதிகமா இருக்கும். அப்ப ஃபர்ஸ்ட் நம்ம இந்த ரெண்டை தான் பார்க்கணும். 3p 4s 3p 4s ரெண்டுமே சேம் வேல்யூ பட் n வேல்யூ எதுக்கு கம்மியா இருக்கோ அதுக்கு தான் எனர்ஜி கம்மியா இருக்கும் அப்ப 3p க்கு அடுத்து 4s வந்துரும் அதுக்கு அப்புறம் தான் 3d வரும் 5 இப்போ 5 ல பாத்தீங்கன்னா ரெண்டு இருக்கும் 2 5 ஓகே சோ அப்ப எதை பார்ப்போம் n வேல்யூ இருக்கும் சோ n வேல்யூ இஸ் n 3 4 so 3 அப்போ next 3d orbitals 3d and next 4p the increasing order 4p right 5 next 5 right so the same value 5 in 3 times the same value 5 in 3 times 5 மூணு இடத்துல 5 இருக்கு அப்போ நமக்கு n வேல்யூ வச்சு தான் சொல்லணும் இதுக்கு n 3 அதனால 3d இதுக்கு n 4 இதுக்கு n 5 ரைட் அப்போ ஃபர்ஸ்ட் 3d அப்புறம் 4p அதுக்கு அப்புறமா 5s நெக்ஸ்ட் 6 ல ரெண்டு இருக்கு 6 ல 2 இருக்கு ஒன்னு 4d இன்னொன்னு 5p 4d 5p which one is n value is least in 4d next 4d 5s 4d next 5p next 5p next 7 1 2 3 4 times in 7 okay so 4 times 4f next 5d next 6p and next 7s okay so 1 2 3 4 so 4 orbitals having same n plus l value in 7 right so the which one is n value is least the energy are also least okay 4 5 6 7 so next 4f 5d 4f 5d right and 6s orbitals 3 times in 6 right 6 are also 3 times so 6 4d 5p the next one 6s too right 6s okay so 1 2 3 times 6 value are you right so 5p and 6s next 7 4f 5d 6p and 7s 6p and 7s next value so 8 1 times and 2 times okay so 8 2 times so 1 time and 2 times in 8 5f and 6d 5f and 6d are you right 5f 5 plus 3 8 6d 6 plus 2 8 okay so 5f 6d the least n value 5 so next the next order 5f and 6d 5f and 6d are you right so next 8 the 9 so 9 6f 6d 6f are you right 6d 6f 6f is 9 okay so 8 next 9 L rule according to n plus L rule the increasing order of energy the energy of orbitals the increasing order of energy of orbitals okay the previous order is not true so only obey in hydrogen atom only so obey hydrogen atom only in multiple electron system in multi electron system in the above system is failure okay in n plus L rule in n plus L rule the energy of orbital increasing order 1s 2s okay less than 2p less than 3s less than 3p and less than 4s and 3d 4p 5s 4d 5p 6s 4f 5d, 6p, 7s, and 5f, 6d, and 6f. Right? Another one, simple method. In another one, simple method to draw the triangular. Draw the triangular. Yeah? Triangular. 1s, 2s, 3s, 4s, 5s, 6s, 7s. Alright? 2s, 3s, 4s, 5s, 6s, and 7s. Are you right? In p orbital, 1s, 2s, 2p, 3p, 4p, 5p, 6p, 7p. 2, 3, 4, 5, 6, 7p. Right? And next, so two line. In above the two line, indicate d orbital. 3d. 4s, 3d. Right? 3d, 4d, 5d, and 6d. 3d, 4d, 5d, 6d. Okay. So next, and less than next two are last two lines. Okay. So above the two line, in 6s, then 4f, 4f, and 5f. 4f and 5f. Right? Okay, students, listen. So the least energy to higher energy. 1s, 1s. 2s, 2p, 2s, 2p, 3s, 3p, 3p, 4s, 4s, 3d, 3d, 4p, 4p, right? 5s, 5s, 4d, 5p, next 6s, 4f, 5d, 6p, and 7s, 5f, 6d, 6d. Right? So the energy level. Energy level. Okay. So very simple method. Okay. So முக்கோணம் drawing triangular ஒன்று போடுறீங்க. அதை போட்டு 1s, 2s, 3s, 4s, 5s, 6s, 7s அப்படின்னு சொல்லி 1, 2, 3, 4, 5, 6, 7 இப்படி பண்ணிருங்க. அதுக்கு நேரா ஒரு லைன் போட்டுருங்க. இந்த பக்கம் p ஆர்பிட்டல் 2p, 3p, 4p, 5p, 6p, 7p அப்படின்னு வச்சுக்கோங்க. ஃபர்ஸ்ட் ரெண்டு லைனா விட்டுட்டு 3d ஆரம்பிங்க. 3d, 4d, 5d, 6d. அடுத்து நீங்க ஆரம்பிச்சீங்களா 3d, அதுல இருந்து ரெண்டு லைன் வச்சுட்டு 4f, 5f எழுதிட்டு இப்போ இந்த ஆர்டர்ல அப்படியே எழுதணும் அப்படின்னா இந்த correct increasing order. Okay. So next, the next one is degenerate orbitals. Degeneracy means equal energy. So equal energy orbitals, already you know that the three possible orientations are available in p orbitals. So three orientations are possible in p orbitals. So in p orbitals, so three possible orientations, namely px, py, and pz orbitals. Px, next orbital px, py, and pz orbitals. Okay, so three orientations are possible in p orbitals, namely px, py, and pz. The three possible orbitals are in equal energy. Equal energy is called degenerate orbitals. So degenerate orbitals mean equal energy orbitals. However, in presence of magnetic or electric field, the degeneracy is lost. In 2p orbital, presence in magnetic or electric field, the three different energy possible orientation is available. Px, Py and Pz. The degeneracy is lost. The energy difference is occurs. The Px is release energy, then Py and Pz. Right? So the energy, the equal energy is lost in presence of magnetic and electric field. Okay, students. The next one is effective nuclear charge. Effective nuclear charge in multi-electron atom. In multi-electron atom. For example, sodium Na, atomic number 11, 281. In multi-electron atom, sodium, in first orbital 2 electrons, in second orbital 8 electron, 2, 4, 6, 8. 2, 4, 6, 8 electron. In last orbit, 1 electron. In multi-electron atom, the two forces are available in this atom. One is the electrostatic attractive force. The electrostatic attractive force between the nucleus and electron. The one force is the electrostatic attractive force between the nucleus and electron. In another one force is repulsive force among the electron. The repulsive force among the electron. The two forces are operating in opposite direction. The two forces are operating in opposite direction. Thus results, right? The decreases in the nuclear force on electron. Nuclear force on electron. Right? The two forces. One is the electrostatic force between nucleus and electron. And another one force is a repulsive force between among the electrons. Thus two forces are operating in opposite direction. This results the decrease in the nuclear force on the electron. Nuclear force on the electron. The net charge experienced by the electron. The net charge experienced by the electron is called effective nuclear charge. Effective nuclear charge. This effective nuclear charge depends upon the states of the orbital. Shape of the orbital. S orbital spherically symmetric. Okay, S orbital, so spherically symmetric. And p orbital is dumbbell shape. P orbital is dumbbell shape. And d orbital is clover leaf shape. Clover leaf shape. So effective nuclear charge depends upon the shapes of the orbital. And it decreases with the increases in the accidental quantum number L. In L value 0 in S orbital, in L value 1 in P orbital, in L value 2 in D orbital. To increase the L value, the effective nuclear charge decreases. In the same orbital, in S, SP, SPD and SPD orbital. Okay, so same orbit, in different orbitals, S, P, D and F orbitals are there in same orbit. Okay, so the effective nuclear charge, the order of effective nuclear charge is greater in S orbital. So says in spherical in shape, the effective nuclear charge increases. then p and d orbital. So the order of effective nuclear charge in same orbit, s greater than p greater than d greater than f. The effective nuclear charge increases, the stability also increases. The greater the effective nuclear charge, the effective nuclear charge is greater, the stability are also greater. The stability are also greater. The energy decreases. The energy decreases. The order of energy in the same orbit, presence in the orbital S less than P, less than D, and less than F. The effective nuclear charge is greater. The effective nuclear charge is greater. The stability are also greater. The energy is decreases. Are you right? The effective nuclear charge is increases. The stability are also increase, but the energy is decreases. More stable, less energy. Less stable, more energy in the orbital. You right? The next point, the energy of the same orbital. The energy of the same orbital decreases with an increases in the atomic number. The atomic number is increases. The atomic number is increases. The energy of same orbital is decreases. The same orbital energy is decreases. Right? The increases in the atomic number. The increases in the atomic number. The energy decreases in the same orbital. For example, in 2s orbital in hydrogen atom. And 2s orbital in lithium atom, in 2s orbital in sodium atom. The 2s orbital in hydrogen atom is more energy than the 2s orbital of lithium. And 2s orbital of lithium is greater energy than 2s orbital in sodium. The increase in the atomic number 1, atomic number 3, and atomic number 11. The increase in the atomic number in same orbital 2s decrease the energy. The energy is decreases. Alright? The inner electron. In an inner electron orbital is increases. The effective nuclear charge is decreases. The effective nuclear charge is decreases. Are you right? So the less stable, more energy. Less stable, more energy in hydrogen. The energy value En is equal to minus 1312.8 into Z square by N square. Z square by N square. To increase the atomic number. To increase the atomic number, the negative value is decreases. The decreasing negative value to increase the energy. Increasing the energy. Are you right? So 1 square. Right? 3 square and 11 square. 11 square. So the negative value is increases. The energy are also decreases. Energy decreases. Are you right? So increase in the atomic number. Atomic number increases. In the same orbital, 3s orbital, the energy is decreases. Energy is decreases. Right? Okay, students. Thank you, students. We'll meet next class.